This is flip number 2 for APES, chapter 17 and 18 on the atmosphere and global climate change. So we were talking earlier about the greenhouse effect and the ozone layer. And one thing about the ozone layer that you need to know is what it actually blocks for sure. And UVC, there's UVC and UVB and UVA light. And these vary in intensity and frequency. And so UVA pretty much is let through. Then there's UVB, which some of it is allowed to come through. And UVC is what it totally blocks. So ultraviolet radiation, this UVC radiation is the kind that has really short wavelengths and it's really intense. UVB has longer wavelengths, not as intense as UVC, and UVA has really long wavelengths. It doesn't mean that these A and B do not cause damage to living tissue, but it definitely blocks the most intense. We talked about how the atmosphere has changed since the start of the Industrial Revolution, and that is because some of our practices, really the byproducts of those practices, of the combustion of things, go into the atmosphere. So we've actually added chemicals to our atmosphere, and that has enhanced the greenhouse effect. Some of the major chemicals that we've added to the atmosphere include carbon dioxide, methane, nitrous oxide, and CFCs. And all of these gases are heat-holding gases. And as you can see here, just these general diagrams, they all pretty much have the same thing going on, where they are increasing in our atmosphere over time. As you can see here, the CFC one, this is actually a synthetic gas, chlorofluorocarbons, and you can see here that it was not in the atmosphere prior to the 1950s. And that's simply because it wasn't created yet. So once we created it, we obviously used it in products, and then we see the outcome of that, how that has gone into the atmosphere. CFCs are used as a kind of a coolant for refrigerants and aerosol cans to increase pressure as well. And now, thankfully, chemical engineers, environmental chemists have been able to stop the use of them in our products by replacing it with hydrofluorocarbons, which pretty much do the same thing but are less environmentally negative. We do still produce CFCs in the United States, and we export those to other countries, but we don't use them in our products. So it's a little hypocritical if you want to think of it like that, where we still make it and export it, but we don't use it in our products. So it's all one atmosphere, right? It's one thing to bring up is that it's a commons. Not any one country or person owns the atmosphere. We're all part of the atmosphere. Whatever we put into it, it's going to go downwind somewhere else. And that even holds true for within our country, how urban areas generally produce more pollutants. Those pollutants don't just stay in urban areas, they will continue to diffuse throughout the atmosphere and even go into rural areas. And we can get into the whole like who pays for damages thing, because it is a somewhat of a non-point source pollutant when it's now in a rural area. So we'll get into that later. We talked about this already because I went off on a tangent before. Warmer planet, yes, we do have a warmer planet, and that is a result of a number of factors, including less ice. With less ice, then there's less reflection of the ultraviolet radiation and solar heat coming in, and therefore that heat goes into the oceans, which causes thermal expansion of the oceans. With thermal expansion of the oceans, then you have warmer temperatures, you have an increase in this, you should write this stuff down, an increase in the amount of evaporation of the water, and then you have more water vapor in the atmosphere, which leads to severe storms, as evident by the typhoon last week, which I meant to talk about last week, but curriculum gets ahead of you. And so they're saying, I don't know if you've seen on the news that typhoon is the largest in history, and we'll see about that. But it doesn't mean that one specific event, that one typhoon, is a piece of data to support. Well, I'm not saying that typhoon is caused by global climate change. But what we can do, and it's so important that we all remember this, is add it to the database. It's just another piece of data that looks remarkably similar to other pieces of data regarding huge, massive storms. That storm, they say, was 20 miles wide. That's how huge that typhoon was. Unbelievable. So again, with global climate change, it's very important that we just keep adding to that database. Similar data, obviously, to support that. This here is a positive feedback loop. And I don't know if any of you were thinking of that when I was talking about it in the first lecture. Because what you have is a change in one direction, which leads to further change in the same direction. And if you remember, a positive feedback loop starts out as a problem this big. So let's say we are burning fossil fuels. As a result of burning fossil fuels, we're putting pollutants into the atmosphere. Okay, those pollutants in the atmosphere don't just hang out and not do anything. Those pollutants can be considered primary pollutants, and primary pollutants are pollutants, the original pollutants. Those are the ones that are emitted directly into the atmosphere from whatever practice it is. And then these primary pollutants can become secondary pollutants. And secondary pollutants in the atmosphere are basically pollutants that from the primary react with one another. So it could be a primary pollutant reacting with another primary pollutant to create a new pollutant. So we call those new pollutants secondary pollutants. So it's not just primary and primary reacting together to make a secondary. It could be primary pollutants reacting with naturally occurring gases that are already in the atmosphere to create a secondary pollutant. We'll get into that later. So that's one way that it creates some issues because in the atmosphere. Now over here, another way that it can become a bigger problem is the fact that those pollutants hold heat. So there we go. When you hold heat, it creates larger storms and thermal expansion of the oceans, and that leads to damage and death. They originally estimated that typhoon killed 10,000 people, and they're still figuring that out right now as they uncover and clean up the area in the Philippines. It's just awful. So, I mean, and that can keep on going on. Since there's a lot of people who have died, you then have lots of people laying around that have passed or deceased, and now you have even more issues with regards to sanitation. And then sanitation leads to spread of disease. Oh boy, these spheres are getting larger and larger and larger. So I don't know if you get what I'm saying here. It just keeps on going around and becomes larger, larger, larger as the change occurs and goes in one direction. The ways in which specifically the elements that have caused the huge change in our atmosphere as a result of our practices include the carbon element, nitrogen, sulfur. Those are the big ones. And it's all because, if you look here, we burn fossil fuels. Fossil fuels give off every one of these in some way, some kind of compound. The way that we have overloaded these cycles, the way that we have maybe removed too much, is all explained here. And if you look here, all three of them, the burning of fossil fuels causes an increase in each of these because in some way, some carbon compound is released as a result of the combustion of fossil fuels, like CO2 or even just CO, carbon monoxide. Another way that we have disrupted this cycle is by cutting down trees, because then you have less trees taking in carbon for photosynthesis, and therefore there's more carbon in the atmosphere. Nitrogen, another one. The big thing here is not only fossil fuels, but fertilizers. We've synthetically created inorganic fertilizers like nitrogen, and by doing that, we are releasing more nitrogen into the atmosphere because we've applied more nitrogen to the land. So nitrogen doesn't stay on land, it goes through its cycle, and it's a fairly fast cycle, if you remember. It's also the most complex. And most of the oxides that are released, these nitrous oxides, eventually will become nitric acid and nitrate salts. And these will completely change the pH of water and of soil, and pH determines the chemical climate of soil. So therefore, if the pH is off, then all other processes and rates of absorption will be affected. And that places organisms outside their range of tolerance, which could lead to death. Sulfur, again, burning fossil fuels. But another big thing here is refining petroleum. When we take oil out of the earth, we have to refine it, meaning that we have to clean it and separate it to make it useful for many things. And so during that process of production of petroleum, we release more sulfur into the atmosphere than natural processes. And the sulfur is in the form of sulfur dioxide. That sulfur dioxide mixes with water again, and that forms sulfuric acid. So here we have another acid thing going on, same type of impact as nitrogen. I mentioned earlier before primary and secondary pollutants. Again, this is just written out here. Primary are emitted directly into the atmosphere. Secondary is when primaries react with one another, or a primary reacts with a natural component in the air. Some examples, which you probably should know, of primary are suspended particulate matter, which is like soot, and then sulfur, carbon, nitrogen oxides, methane. Those are all primary. Secondary pollutants are things like peroxystyl nitrates, which are referred to as PANs, hydrogen peroxide, nitrate, sulfate salts, nitric acid, vapor, and ozone. And there is a table on page, let's see here, it's 422 to 423 that I would like you guys to read over and make sure you're aware of the different types of common criteria pollutants, air pollutants. This is in the United States. All right, I'm going to stop this lecture here and we'll move on.